Yes, you are told you find them. Find the turning point. The turning point. Now this curve. Now this curve. So the turning points. So the turning points, we also call them the stationary points. The turning points, we also call them the stationary point. So when you talk of turning point, we talk of the gradient function yake is always equal to 0. So dy dx equals to 0. So therefore, when you differentiate this, then equal to 0, then get x. It will be 2 minus 2 times 4, 8x. That's the dy dx. So starting point dy dx equals to 0. So equate this to 0. 0 equals to 2 minus 8x. Bring this on this side. This one you get 8x equals to 2. So our x is equal to 2 over 8, which is a good. Which is a good. So our value of x is equal to a quarter. So you could like that. Then, if you get a quarter, then go back to the original equation or the function, this one, and you find y. 6 plus 2, x is a quarter, minus 4, bracket, a quarter squared. For you to find y, substitute that and find y. Substitute that one and find your y. Minus 4 times 1 over 16. So 6.5 minus a quarter. The 6 and a quarter. So that's 6 and a quarter. You get that one is 6 and a quarter. So that's the value of y. So therefore, your turning point, the turning point, the one that you also call the stationary point, will be equals to a quarter, because x is a quarter, and now y is 6 and a quarter. Those are the turning points, or that is the turning point. That. So 6, this is a quarter, and this one is 6 and a quarter. So that is the point. So that's how you find the turning point. That's how you find the turning point. So you are given this function, y is equal to x cubed minus 3x plus 2 there. So you find the stationary points. Now, you are supposed to find the dy dx of this function. It becomes 3x squared minus 3. Because you're not differentiating this function. So you get 3x squared minus 3. So therefore, at stationary point, dy over dx is always equal to 0. So take 3x squared minus 3 equal to 0. 3x squared minus 3 equals to 0. So what you do, you can divide by 3. Even 0 divided by 3. You take x squared minus 1 is equal to 0. If you take this one this side, assuming you have taken like that, you get equals to 1. Then your value of x is always equal to the square root of 1. And the square root is always plus or minus. So therefore, the value of x is plus or minus 1. So one value of x is equal to 1. The other one is x equal to minus 1. It's equal to minus 1. So that's why you are getting 1 point. Because you've got the square root of 1 is 1. It should be plus or minus 1. So get 1. So therefore, can you find the two values of y now? The two values of y. Get the two values of y. We have y is equal to x cubed minus 3x plus 2. Plus 2. So take x is equal to 1. So y is equal to 1 cubed minus 3 into bracket 1 plus 2. So take this, you say y is equal to 1 minus 3 plus 2. 1 plus 1, 1 plus 2, 3 minus 3, that's it. So y is 0. So one of the points is 1, 0, because you have substituted 1. That is 1, 0. So take the second point. That's the first point. That's the first stationary point. Then get this one. When x is -1, take this. Y is equal to x cubed minus 3x plus 2. When x is -1, y equals to -1 cubed minus 3 bracket -1 plus 2. So what do you get? -1 plus 3 plus 2. -1 plus 3 plus 2. This is 4. That's 4. So our second stationary point will be -1, 4. Will be -1, 4. Be -1, 4. So part B, you are told determine the nature of the stationary point. So to determine the nature of the stationary point, this point, we have three stationary points, types of stationary points. We have one called maximum, we have another one called minimum, and we have another one called point of inflection. We have those three. So you are supposed to determine whether 1, 0 is a maximum, minimum, or point of inflection. So let's see. How do you get this? Now, I'll use the first derivative method to get this. What you do, you take this point 1, 0, and then you take your point x, and then divide by dx. dy and dx. So our function dy dx is what? Our function dy dx is 3x squared minus 3. Then you get, I want us to use the first derivative. You take these values of x itself. You want to determine 1, 0. You put it here. You put it at the center there. Then what you do, you move a little step to the right, one step to the right, and one step to the right. An integral step, that's a whole number step. So from 1, you go to 2. And from 1 on this side, you go to 0. I want you to substitute these values here. I want you to substitute. If you substitute 1, the one given here, this value dy dx must be equal to 0. You can try. 3, 1 squared is 1 times 3 minus 3 is 0. That's okay. Where can 0? 3 times 0 squared, 0 minus 3 minus 3. 2 squared, 4 times 3, 12 minus 3, that's 9. When you get that, I've used the first derivative. This value is minus or negative, 0, and then positive. There is what we call the diagrammatic representation. Diagrammatic representation. Diagrammatic representation of stationary point. Diagrammatic representation. So diagrammatic. Yes, because you need a diagram, a diagrammatic representation. So this one we say when it is negative, it moves like this. It's like moving downward, negative. Then go to 0, then goes start upward like that. So it's like this. So there's negative, 0, and positive. So while this gradient function is moving from negative value, 0, then to positive value, from negative, 0, positive, this point here, we say it is a minimum point. That's a minimum point. So your graph, when you plot, it will look like this. So that this point, it will look like this. It will look like this. Because it's minimum. So this point, that's where dy dx will be equal to 0. But on this side, it will be negative. Towards the right side, it will be positive. So therefore, this point will be minimum. And therefore, the point given here is a minimum point. This is a minimum point. That's a minimum point. Now, so the second point to determine whether it is minimum, maximum, or point of inflection is -4, 1. The same procedure you have used, because we have used the first derivative, you also use the same. This is the value of x is -1. One step towards the right, this will go to 0. One step towards the left from -1, it will go to -2. If, because there's -1, if you substitute -1 here, you substitute -1 here, you get this is 0. And you can try -1 squared is 1 times 3 minus 3 is 0. Put 0 here, put the right 0 here. That's negative. That's negative. That's negative. So then the other one will be, you come to this -2 squared, that's 4, times 3, 12 minus this one, 9. Then from there, can you check whether this point, this is a positive value, this is 0, this is what? A negative value. Again, the diagrammatic representation of this is like this. It moves, it's like it's moving towards, it is now positive, then goes to 0, and then it goes to negative. So this one, positive there, the dy dx is there, this is 0, and this minus. So this one point, we call it a maximum. And our point here is maximum. Positive, 0, negative. It's like it is moving up, then at the stationary point, then at the stationary point now, the dy dx here at this point is 0, and then you get that. So this is at the turning point. Then it starts going to the negative side. So that's the gradient function. Then this point is called a maximum point. That point is called a maximum point. So in what circumstance do you say that the point is point of inflection? Point of inflection, inflection, in this case, is got when this is x and this dy dx. And you have the 3 values here. X, you have the 3 values there. You have those 3 values. We get it when this is 0, this is, let's say this is 0 there, this positive and this positive. All negative, 0 and positive. Sorry, negative, 0 and negative. So this is when you get that you say a point is a point of inflection. That it moves like this. The grammatic when it is positive, like that and like that. Positive, 0, positive. Or it moves downward now. It moves downward. It moves downward like that. This is negative, 0, negative. This is the one we talk of point of inflection. Point of inflection. Point of inflection. That's we call it point of inflection. Now sketch this curve. Sketch the curve for this one. For 1, 0 and negative 1, 4. So when you want to sketch the curve, you must use these 2 points. This point is minimum, and this point is maximum. We have got that. Therefore, you only need this point. Y is equal to x cubed minus 3x plus 2. In this case, you say, where does this one cut y-axis? And where it cuts the x-axis. Those are the only 2 points, more points that required. At y-axis, x is equal to 0. Where x is 0, y will be equal to 0, 0, this is 2. So the other point is 2, 0. That's point. So you say at y-axis, because you already have the stationary points, and you already know the nature. This one then, you say at y-axis, x equal to 0. And then, what about at x-axis? At x-axis, the value of y is 0. So it puts 0 here. This function 0 is equal to x cubed minus 3x plus 2. But when it is like this, you cannot be able to solve this EQ because this is x cubed, it is not squared. You cannot solve this equation here. When it is like that. But when you go back to the point, we have one point where when x is 0, when y is 0, x is 1. And the point here is 1, 0. And you already knew for this question, it is 1, 0, because when y is 0, x is 1. Are you together?
Yeah.
Yeah, when y is 0, x is 1. So therefore, 9 point is a minimum point. That's what you said, a minimum point. So you sketch now the path. You sketch. It's not accurate, it is sketching. So when you're sketching, this point is 0. You say, we're going to point 1, 0, the minus 1, 4. Point 1, 0 can be here. That's it is there. 1, 0. Or I put it here. That is 1, 0. Point 1, 0 is there. So, and this is the exact 9y. You are sketching. And 1, 0 is a minimum point. 1, 0. 1, 0 is a minimum point. Meaning, at this point, it will move like this. That because it's minimum. Then the other one is maximum, negative 1, 4. Let's say negative 1 is there, and 4 is here. Negative 1, 4. This point is what? Negative 1, 4. It's a maximum point. We have got that. That point is a maximum point. Is that true?
Yes.
Yeah, so it will move like this. And then the last one is 0, 2. 0, 2 equal. That's 2 is 0. So this point is 0. So this graph passes through this point, this one and this one. And this one is minimum, and this maximum. Well, this is maximum. This graph, your graph will move like this. Will move like that. Like that. Comes to 1, 0. At this point 1, 0, because it is minimum, it will move like that. So you do not just join this, and this one. You must show how the curve is moving. Is that okay?
Yeah.
And you have already sketched the curve. So this maximum, this minimum, and then you have 1 point there. So that's what you get.